Okay, so today we're looking at how to sketch the derivative function. So our learning intention is to gain the knowledge in reading a graph of a function and constructing the graph of that derivative. Okay, so we'll be successful if we can identify where stationary points are. That is when the gradient is 0. Identify when the original function is increasing or decreasing, and then be able to construct the graph of the derivative when given the original function. Okay. So we want to sketch y dash if we're given y. So this is the original function, f of x. I'm going to sketch the derivative. The first step that I do is find stationary points. So step 1 is find stationary points. And in this graph, the stationary point is here. All right. So we're going to mark, so x is 0, we're going to mark that point on the x-axis of your derivative graph. Okay. So find stationary points and mark these points on the x-axis. All right. So between stationary points, so I've only got one, right? So I need to look at the stuff that's happening on the left, and here the function is decreasing. So where the function is decreasing, we draw this under the x-axis. So what I'll do is I'll just shade it like this. Okay. Now look at the other side of the stationary point, and here my graph is increasing. So where the function is increasing, we're going to draw that above the x-axis. So if I shade that, it's somewhere up here. So now what I want to do is obviously it's down here on this axis when it's negative infinity to 0, and it's above the x-axis from 0 to infinity. So the function of the derivative for this parabola is a straight line. Okay, we'll do another example. So using the first step, I want to mark where stationary points are. It's probably more. Okay, so I've got a stationary point at -1, and then I've got a stationary point really at 1.7, I would say. Okay, so from -1 to infinity, the function is decreasing, so I'm going to draw it under here. From -1 to 1.7, it's increasing, so we're going to draw it up here. And from 1.7 to infinity, it's decreasing, so we're going to draw it down here. So this cubic is creating something, the derivative function that looks something like this. Okay. One more example. All right, so we're going to do stationary points first. So when the gradient is 0, so I've got a -3, I'm going to mark these on the x-axis. -1, 1, and 3. Alright. From -infinity to 3, the function is increasing, so I'm somewhere up here. From -3 to -1, it's decreasing. From -1 to 1, it's increasing. From 1 to -3, it's decreasing. And then from 3 to infinity, it's increasing. So it looks like just going between the regions, increasing, decreasing, increasing. Okay, and that's how we're going to draw the derivative function based on the original function. Find stationary points, identify where the function is increasing or decreasing. If it's increasing, we draw the new function above the x-axis. If it's decreasing, we draw below the x-axis. Okay, good luck.